Hi there. Welcome to the wild world of sediment and sedimentary rocks. People, this is some fascinating stuff, so get ready for some excitement. The pictures on the left, you have some of the sedimentary rocks that we see in the area of Sedona in Arizona. Picture in the middle are some of the sedimentary rocks that you can see from the south rim of the Grand Canyon, also in Arizona. And the picture on the right is one of those little treasures that we find in the hill country of my home state of Texas. These are the sedimentary rocks that we see in the area that we call Pedernales Falls. Now, who am I? My name is Robert Font. I have a PhD in the geological sciences from Texas A&M University. Uh, I also have now more than 50 years of professional experience. That gives you an idea how old I am. Um, I am a certified professional geologist, as recognized both in the US and Europe. And believe it or not, my work has taken me to more than 50 countries in 4 different continents. Wow. I decided to break this topic into 7 different parts or 7 different videos. Uh, Part one is an introduction that we are already going through and the key concepts of the rock cycle and the hydrologic cycle. Part two involves sediment development. That involves the process that we call weathering, and weathering can be divided into physical weathering and chemical weathering. Part three is a very brief review of some of the most critical soil types under formation. Part four is the entire process from sediment creation to the creation of sedimentary rocks. It involves erosion, transportation, deposition, and lithification. That's just the fancy term that we use to signify that we're transforming sediment into sedimentary rock. Part 5 is an illustration of the process discussed in Part 4, but I'm specifically using the fluvial example, rivers and streams. Part 6 is a discussion of sedimentary rocks per se, uh, both the clastic sedimentary rocks and the non-clastic sedimentary rocks. And part 7 talks about the different environments of deposition and the different sediments and sediment types that you find associated with these environments. Now let's talk about the concept of the rock cycle. It is a cycle, so we can start anywhere. So let's start at the bottom with magma. Magma is molten rock that is found below the surface. When that molten rock is on the surface, we call it lava. This magma or lava will crystallize or solidify, giving you what we call an igneous rock. Uh, Igneous rocks that are exposed at the surface are subject to the weathering agents, such as running water, ice, wind, biological activity, etc. The bottom line is that these rocks are going to break down physically and perhaps chemically and create sediment. So sediment is, in essence, this broken down rock material. The sediment is going to be eroded, which in essence means it is going to be transported from its place of origin to a resting place, because at some point in time the erosional agent is going to lose its energy and the sediment that it carries is going to be dropped, what we call deposition. These sediment layers can be buried, compacted, and cemented, and undergo the process that we call lithification, which again is the process of the transformation of sediment into sedimentary rock. Sedimentary rocks can be buried, and through the action of heat, pressure, and chemical solutions, without going through a molten state, they can be transformed, they can be metamorphosed and create a new rock type that we call metamorphic rocks. Metamorphic rocks can be heated and melted, and you're back to a magma, completing the cycle. There are some shortcuts to the cycle. For example, igneous rocks can melt directly and create new magma. Metamorphic rocks can weather, giving rise to sediment. Igneous rocks can metamorphose directly, and sedimentary rocks can also weather, giving you new sediment. Those are the shortcuts to the cycle. In this series, we're going to concentrate on sediments and sedimentary rocks. However, since I mentioned the rock cycle, and since all rocks are really related in some way or another, I should mention examples of the igneous, the sedimentary, and the metamorphic rocks at this time. I selected two igneous rocks to mention to you because they're critical to us in the world of geology. One is granite, the other one is basalt. Granite is the main component of the continental crust. Basalt is the main component of the oceanic crust. The picture on the left, I'm standing on granite in Cadillac Mountain in the beautiful state of Maine in the US. Picture on the right, I'm standing on a pahoehoe, dig that Hawaiian, that's Hawaiian lingo. I'm standing on a pahoehoe lava flow in the big island of Hawaii in the US. Well, we're concentrating on sediments and sedimentary rocks. So these rock types are critical to us here. Some of the most common sedimentary rocks are sandstone, limestone, and shale. In the pictures that I'm giving you here, I'm showing you examples of each. The picture on the top left is a cross-bedded sandstone that we find in the state of Arizona. The picture to the right is a massive limestone that we find in north central Texas. The picture on the bottom is a shale composed mainly of clay along with a landslide, and this is found in the city of Waco in Texas. The most common metamorphic rocks are slate, schist, phyllite, gneiss, quartzite, and marble. The picture on the left is a shale turning into a slate, as we see in Alaska. Next to it is a picture of gneiss. Gneiss is metamorphosed granite. But if you notice the banding, what we call foliation, that indicates that this rock has been subjected to tremendous pressures, realigning the minerals in it. So we know this is a metamorphosed granite that we call gneiss. Next to that, I'm standing on an outcrop of phyllite. And last but not least, the picture on the right is a large cobble made out of quartzite. Another cycle that is critical to us in the understanding of sediments and sedimentary rocks is the hydrologic cycle. It is important in the understanding of erosion, sediment transportation, and deposition. It all starts with the process of evaporation, sublimation, or transpiration in which water is introduced into the atmosphere in the form of water vapor. Evaporation takes place from large bodies of water like the ocean or lakes. Sublimation is the evaporation of ice directly into water vapor, not going through a liquid state. That happens in glaciated areas or areas where you have ice sheets, so that water vapor is introduced into the atmosphere. You can also have transpiration, which is the loss of water from plants as water vapor into the atmosphere. So once you have this water vapor in the atmosphere, some of these will condense into clouds, some of these clouds will burst open, and you will get precipitation in the form of rain, snow, ice, whatever. Once this water reaches the surface, it will run off, form part of rivers or streams, or it would percolate or infiltrate into the ground, and through the influence of gravity, you have groundwater flow. Eventually, this water makes it back to the ocean and lakes, large bodies of water, and the cycle is completed. Here are two examples, one of runoff and the other one of the effects of groundwater flow. The picture on the left, you have two streams that are joining together in a fascinating area of the world. This is the area that we call Lattefossen in Norway. The picture on the right is a system of tunnels that you find within the Longhorn Cavern system in Texas. These tunnels, this cave system was sculpted through groundwater flow. Okay, see you in part 2.